So the next topic that you can explore is around chaos, bifurcation diagrams, and Lyapunov exponents. And so it's just an introduction. And so you can start with the definitions and explanations in the book of Strogatz. This is a classical one, non-linear dynamics and chaos. So you look there for bifurcation diagrams and Lyapunov exponents. And here, for example, is the logistic iteration. So you look at the R, look, f of x is the function R times x times 1 minus x. And you iterate that. I'm pretty sure you have already seen that. And as you move the parameter R, the dynamics are becoming more complicated, and you have the apparition of chaos. And one of the property of chaos is that two very close initial conditions will be exponentially far away after a certain amount of time. So it is when explained in this book of Strogatz how from there you can define Lyapunov exponents. And so just I took one code of this book, just it's easy to reproduce this code, to copy this code and to obtain those pictures. So you can have a look at that and see how things are defined. So here you have the bifurcation diagram. As R is varied, you look at typically at the cross section when we cross some tangent space, and here, so it's more so the omega limit sets of an initial condition. So what this bifurcation diagram represents. So you start with R, you have a fixed point that will attract the trajectories. At some point, this bifurcates and you no longer have only one single attractive point, but a periodic attractive solution. So, and then you have the period doubling because you have 2, then 4, then 8, then 16. And then at some point you cannot predict what you have, and you have that some lines are dense in an interval. All right. Okay, and this is related to a positive Lyapunov exponent. So everything is well explained in the book. So you can see here for a certain R in red, the Lyapunov exponent becomes positive. And so this means that you have sensitivity to initial conditions. All right. So this is quite fast. It is just the idea. Again, this is just to introduce the topic, and so it is worth for you to delve more into that. So the next point is just to go through some papers. So you can just look at the definitions of what is a strange attractor, have a look of the concepts introduced in this paper. And then you have also this one, or also the one of Lei Songyong and Kevin Lin, who makes the link between these strange attractors, chaos, and limit cycles and Hopf bifurcations. So the material will be posted online, and so you can have a look at this. Point 4, you can find this paper on arXiv, and it's interesting because it gives you some interesting oscillatory phenomenon for both a PDE and a three-dimensional ODE with 3 time scales. And finally, you can also have a look at what is the topological degree theory. And also in the same paper as before, you have a proof for the existence of an elliptic solution, for the solution of an elliptic equation. So that's it. I hope you will have you'll do a good work, and see you next time. Bye bye.